Sorry. Hi, today we'll be beginning with a new topic, that is trigonometry. So let's try to understand the word trigonometry. From where does the word arise? The word trigonometry comes from three parts: trigo, ono and metron. Trigo, ono, this means three, this can mean side or an angle, and then metry comes from the word metron. So the measurement of three-sided figures or the measurement of figures with three angles, the study of such figures is known as trigonometry. Till class 10th you must have covered the measurement of angles in degrees, let be it 30 degree or 60 degree or 45 degree and so on. This angle measurement system which you were following, the angle measurement system, this angle measurement system was known as sexagesimal angle measurement system, in which the unit of measurement was degrees. If the angle measured was 30 degrees, then the angle measurement system was called sexagesimal angle measurement system. And the thing with that system is that if we are talking about a circle, then the angle made inside a circle is considered as 360 degrees. The point to be noted here is, why is the angle 360 degrees? Why is it not 300? Why is it not 400 or 350? We humans have 10 fingers. When we have 10 fingers, that's why whenever we used to write the numbers during our junior classes, we started from 1, ended at 10. Then in the next column, we started from 11, ended till 20. We were comprising the entire list only of 10 numbers because we have 10 fingers. So when we are talking about the entire circle, why are we considering only 360 degrees? Why are we not considering 300, 400 or 350 degrees? If you know the answer, please put it in the comment. For the rest of you, I'll try to answer that question, and I hope everyone will understand that. Back in the prehistoric times, in the Sadi civilization or Babylonian civilization, people observed that if there is a celestial body, be it a planet or a star, it took roughly 360 days to travel around and go back to its initial position. They were lacking precise instruments, so they assumed it to be roughly 360 days. And from there, this number 360 has stuck. That is the reason why a circle has 360 degrees, because it took 360 days for a celestial body to complete its orbit and come back to its original position. Now with precise instruments, we know that this number is not 360. Exactly, this number is 365.25 days. But because of convention, this has become the default setting and everyone uses the term 360 degrees. So now let's try to understand a new angle measurement system which is going to define the unit of measurement of an angle based on the circle. Let's try to understand what we mean by that line. The angle measurement system is known as radian angle measurement system or circular angle measurement system. Let's try to understand what happens in this system. If there is a circle whose radius is equal to r units, unit can be anything, meters, centimeter, millimeter. So the general term is going to be units. So if there is a circle whose radius equals r units, and I am going to take an arc whose arc length is equal to radius of the circle, that is r, then I am going to say that the angle subtended by this arc whose length is equal to the radius of the circle, this angle is known as 1 radian. So our radian angle measurement system states that 1 radian is the angle subtended by an arc whose length is equal to length of the radius. So if I am talking about a circle whose radius is equal to a units, if this is my circle with radius equal to a units and I take an arc whose arc length is equal to a units, then the angle subtended at the center of the circle is known as 1 radian. Now the beauty of the system is that the angle is measured, the definition of the angle comes from the circle itself. If the radius is r and the arc length is r, then the angle subtended is known as 1 radian. Now let's try to understand a not so important system, but it is also necessary to know, that is known as hexagesimal angle measurement system. And in hexagesimal angle measurement system, the degree As in sexagesimal angle measurement system, we were using degree as the unit to measure the angle. In radian angle measurement system, we were using the unit radians to measure the angle. In hexagesimal angle measurement system, the unit used is called grade. So now that is not much important. So we are going to talk about radian angle measurement system in detail. So now let's discuss radian angle measurement system. Now let's try to understand the system based on unitary method. What we just saw was that if I have a circle whose radius is equal to r units, arc length is equal to r units, then the angle subtended was 1 radian. An arc of length equal to radius subtends an angle of 1 radian. So the reverse is also going to be true. If I say that angle is 1 radian, then what will be the arc length? The arc length is going to be r units. Now units, as we discussed, can be anything, millimeter, centimeter or meter. Now what happens is that in this case, in this circle, I am going to talk about a different case. Let's try to calculate what happens if the angle is theta radians. Now I want you to calculate the arc length if the angle is theta radians. What we know is that 1 radian subtends an arc length of r units. So if the angle becomes theta radians, the arc length will become r into theta. Now this is simple unitary method. For 1 unit, I was having r units. For theta units, I am going to have r times theta, because theta gets multiplied to both the terms. So if the angle becomes theta radians, the arc length is going to become theta r. I hope this is clear. Now let's move forward. I'll try to cover the entire circle now. What do we know? We know that the arc length of the entire circle. What is the arc length of the entire circle? Arc length of the entire circle is also known as circumference of the circle. That is going to be 2 pi r. Now 2 pi r is the entire circle's arc length. What I want to calculate is the angle of the entire circle. If I want to calculate the angle, so I am going to place the angle on right hand side. What do I have? I have the arc length equal to r radius. If the arc length is r radius, now I have to calculate the angle. The angle is 1 radian. Simple unitary method says if the arc length is divided by r, then I have to divide the angle also by r. So the arc length, if it was r units, the angle was 1 radian. If the arc length becomes 1 unit, then the angle is going to become 1 by rth times a radian. Now if I have to find the angle, if the arc length is the entire circle, that is 2 pi r. Now if the arc length is 2 pi r, that is the entire circle. So I am multiplying 1 by 2 pi r. So on RHS also I will have to multiply it. So I will get 2 pi r into 1 upon r radians. R gets cancelled and I will get 2 pi radians. So now if the arc length is 2 pi r, that is the entire circumference is 2 pi r. If the entire circumference is 2 pi r, the angle subtended is 2 pi radians. Excuse me. So now we know, as we discussed earlier, 360 degrees is the same as saying 2 pi radians. This is in sexagesimal angle measurement system. This is in radian angle measurement system. If I divide both sides by 2, I will get 180 degrees equals pi radians. Again, if I divide both sides by 2, I will get 90 degrees equals pi upon 2 radians. If I divide both sides by 2, I will get 45 degrees equals pi by 4 radians. I hope this is clear. Now let's talk about conversion from degree to radian and radian to degree. If I have to convert from radian to degree, what do we know? We know that 2 pi radians is the same thing as 360 degrees. That means 1 radian is the same thing as 360 divided by 2 pi degrees. If I have to convert r radians to degrees, what am I going to write? R radians over here, and I'll have to multiply this term by r. So I'll put r into 360 upon 2 pi degrees. So if I have to convert r radians to degrees, we have to multiply r with 360 upon 2 pi. Now let's have a look at the other case. In the other case, I am going to convert degree to radian. If I have to convert degree to radian, what do we know? We know that 360 degrees is the same thing as 2 pi radians. So 1 degree is the same thing as 2 pi upon 360 radians. Now let's assume we have to convert d degrees to radians. So d degree will be written as d into 2 pi upon 360 radians. If I had to convert r radians to degrees, I multiplied it with 360 upon 2 pi. If I have to convert d degrees to radians, I'll multiply it by 2 pi upon 360. The trick I use to remember it is that if I have to convert to degree, the numerator term has 360. 360 is related to degree. If I have to convert to radian, then the numerator term has 2 pi. If I have to convert it to radian, the numerator term has 2 pi. If I have to convert it to degree, the numerator term has 360. Okay, please note it down, then we'll move forward to the next point. Now let's take another table. If I have the angle and I have to calculate the area of a sector. I hope everyone knows what is a sector. A sector is the part of a circle which is bounded by 2 radii and 1 arc. This is a sector. We have to find the area of a sector. Let's say the angle is 1 radian. If the angle is 1 radian, then I have to find the area of the sector. What do we know? We know that the area of the entire circle is pi r square. Area of the entire circle. If I am talking about entire circle, then what is the area? The formula says pi r square. What is the angle? Angle is 2 pi radians. 2 pi radians has an area of pi r square. Now if the angle is 1 radian, the area will be pi r square divided by 2 pi. Pi and pi get cancelled. I'll get r square upon 2 unit squared. So now this is the formula for area of a sector. Area of a sector when the angle is 1 radian. What does this tell us about the arc length? That it is going to be r, where r is the radius. So the area of this sector is denoted by r square upon 2. So it is r square upon 2. Now let's continue this topic and talk about the next implication. What happens if I have to find the area of a sector whose angle is theta radians? If instead of 1 the angle increased to theta radians, it is going to become theta into r square upon 2 unit squared. So now this is the new area. So now theta radians, the sector whose angle is theta radians, this area is going to be half of r square theta unit squared. I hope this much is clear. Now we'll talk about resolution of vectors, and then we'll talk about an implication of resolution of vectors in the chapter of trigonometry. Let's say I have a vector r. What is r? This is my position or radius vector whose magnitude is equal to r. If the magnitude of this vector is equal to r, I am going to say this is my vector, magnitude is r. Now I am trying to resolve it. If I want to resolve this vector, let's just do a nomenclature of this triangle OA and B. Assume this angle to be theta. Now if I have to find sine theta, what will sine theta be? Sine theta is the ratio of vertical component to the hypotenuse. The vertical component is AB, hypotenuse is r. So I can say that AB is equal to r sine theta. Now if I have to find cos theta, cos theta is the horizontal component upon the radius. So it's going to be OA upon r. So I'll write OA is equal to r cos theta. So now as we just saw, AB is r sine theta and OA can be written as r cos theta. So this side, this can be written as r sine theta, and this side can be written as r cos theta. If I resolve this vector along the angle, if I am resolving it towards the angle, it becomes r cos theta. If I am resolving it away from the angle, it becomes r sine theta. I hope this much is clear. Now we will apply this knowledge in a circle. Let's say this is my circle whose chord is given like this. A, this is B. Okay, now let's observe what is happening over here. This is a chord AB, this is the center C. You must have studied in class 10th that if I drop a perpendicular from the center to a chord, if I drop a perpendicular, it is going to bisect it. So let's call the midpoint as M. Now, if the entire angle is theta, what will this angle be? This is going to be theta by 2, because these two triangles are congruent to each other and they become CPCT, corresponding paths of congruent triangle. So if this is theta, this is also theta upon 2, because these two angles are going to be equal. Now this is the radius of the circle, so I'll call it R. Now let's apply the knowledge of resolution of vectors. If I'm resolving R along the angle, the length of this side becomes R cos theta upon 2. If I'm resolving R away from the angle, then the length of this side becomes R sin theta upon 2. This BM is equal to MA, so this side is also going to be R sin theta upon 2. If I have to find the area of the triangle A, B and C, area of triangle ABC is equal to half into base into height. So I am going to write half into base. What is base? 2R sin theta by 2. Twice of R sin theta by 2. What is height? Height is R cos theta by 2. R cos of theta upon 2. So I can say that the formula becomes R square upon 2 twice of sin theta by 2 cos theta by 2. And after a few lessons, we are going to see that this is the formula for sin theta. So we can say R square upon 2 sin theta. Let's just observe the similarity between the two results. What we earlier studied was this sector, the entire sector from the arc between these radii. Then the angle of this entire sector was coming as half R square theta. Now what we have found? We have found the area between these two radii and this hypotenuse or the chord. This is not the hypotenuse, this is the chord. The area between two radii and the chord. It is R square by 2 sin theta. So if I have to find this area, the recently shaded portion, I'll shade it by this color. This recently shaded portion, this one. This area will be written as half of R square theta, that is the area of the larger body, minus half of R square sin theta, that is the area of the smaller body. If we subtract these two, that is when we are going to find the area of the remaining portion. Now let's talk about another topic, that is going to be polygons. Before we begin, let's just discuss what is a polygon. Polygon comes from two words, poly and gon. Poly means many and gon means angle or side. If any figure has many angle or a side, then we can say that it is a polygon. For instance, in this figure, it has 6 sides, so it is known as a hexagon. Now another definition comes into picture, that is a regular polygon. If all the sides and all the angles are equal, then we call it a regular polygon. So now in this case of a hexagon, if I ask you regular hexagon, if I ask you to find the internal angle, how are you going to do that? It's quite simple. We are going to memorize a formula and that is going to help us to calculate everything. External angle can be calculated by writing 360 degrees upon n. If I divide 360 degrees upon n, that is how I am dividing external angle into n parts. N is the number of sides or the number of angles. So if I'm talking about a regular hexagon, n becomes 6 and the external angle becomes 60 degrees. So this angle is going to be 60 degrees. What will be the internal angle? It's going to be 120 degrees. So we can say that internal angle is going to be 180 degrees minus external angle. So it's going to be 180 degrees minus external angle, that is 360 degrees upon n. If I convert this into radians, this becomes pi minus 2 pi upon n. 180 degrees minus external angle was 2 pi upon n. So now this is the internal angle. If I want to calculate the sum of internal angles, how will I calculate the sum of internal angles? I'll multiply this number by n because there are n internal angles. So n into this becomes n pi minus 2 pi divided by n, and n can get cancelled. I'll write it as n minus 2 into pi. So this is the formula to calculate the sum of internal angles. I hope this much is clear. Please note it down. Now let's quickly revise what we have studied till class 10th. In class 10th, we have studied some basic angles and their values. So let's just recall them a little bit. Sine and tan. Sine and tan, when the angle is 0, they remain 0. What happens to cos? Cos becomes 1. So if I am talking about the values of cos and sec, they are going to be 1. If sine and tan are 0, what will happen to the reciprocals? They are going to become undefined. So sine ka reciprocal is cosec and tan's reciprocal is cot. They will be undefined. So if I am talking about positive x-axis, then sine is 0 over here, tan is 0 over here. Cos is 1, sec is 1, because they both are reciprocals. Now if sine and tan are 0, then cosec and cot become undefined. On let's talk about negative x-axis now. Sine and tan, they are 0 over here, they are still going to be 0 over here. What happens to cos and sec? Cos and sec will become minus 1. The reciprocals of sine and tan, that is cosec and cot, they will become 1 upon 0, that is undefined. Now let's have a look at positive y-axis. On this axis, sine becomes 1, so its reciprocal cosec will also be 1. And the beautiful part is that cos becomes 0, so cot will also become 0. Why will cot become 0? Because cot is cos upon sine, so it is 0 upon 1, that is going to be 0. If cos and cot are 0, their reciprocals will become undefined now. So sec and tan, they will become undefined. That is the reason why tan 90 is written as undefined. Now let's talk about the negative y-axis. On the negative y-axis, as we can observe, sine and cosec are going to become minus 1. Cos and cot are still going to remain 0. But since cos and cot are 0, so sec and tan are going to become undefined. Their reciprocals, sec and tan, are going to become undefined on the negative y-axis. Please note it down. I think this was enough for today. We'll continue from here in the next class. Thank you.